Last piece, complete and incomplete combustion. So complete combustion is where carbon dioxide and water are the only products. Incomplete combustion may include two reactions. So you could make carbon monoxide or you could make carbon. Okay? Now here's the deal. All three reactions occur simultaneously in combustion. How much oxygen is available will determine the ratio that each reaction occurs. So more oxygen, if there's more oxygen, then you have more complete combustion. Less oxygen, the ratio of incomplete to complete increases. All right? So more oxygen present for each mole of fuel creates more complete combustion. This is why you do regular maintenance on your car engine, like change your oil filter and air filter and things like that. Adding alcohol to gasoline also makes combustion more complete because it adds more oxygen. So alcohol has an OH group on it, so there's more oxygen. So that means we have less CO and C created. Okay? So practice examples for this. Page 388, number 2. Page 391, numbers 9 through 11. Page 394, numbers 4 through 7. Page 399, number 1. All those talk about hydrocarbon refining processes. All right? So if we look at these ratios here, we want to look at the oxygen to carbon ratio. So let's say we have this combustion of ethane actually, I'm not going to do this one. I'm going to look at this. So let's say we have complete and incomplete combustion of octane, which is gasoline. So we have 2C8H18 plus 25O2, and that makes 16CO2 plus 18H2O. That's complete combustion. And then here you have 2C8H18 plus 17O2. This makes 16CO plus 18H2O. And you could have another incomplete combustion reaction that creates this. So these are incomplete. Now here's the deal. If you look at the oxygen to hydrocarbon ratio, there's much more oxygen available in complete combustion to burn that octane. Right? There's 25 oxygen molecules for every one octane molecule. But with these guys, you only have 17 molecules versus 9 molecules here. So more oxygen available means we get cleaner fuel that's produced, right? Even though this contributes to the greenhouse effect, right? Carbon monoxide is a poison, and elemental carbon is soot. So we definitely don't want to be breathing either of those in, right? So the larger oxygen to fuel ratio, the cleaner the fuel burns. And this is why we also add alcohol to hydrocarbons that we burn. So if I look at this one, if we look at ethane, C2H6 plus 7O2 makes 4 CO2 plus 6 H2O. And then this, and then we look at ethanol. CO2 plus 3 H2O. Okay, so if I look at adding the ethanol itself, the ethanol burns cleaner, right? So burns cleaner produces less carbon byproduct. So the oxygen, more oxygen available in the molecule itself, right, will make 4 CO2 molecules for every ethane burned here, but only 2. So adding alcohol to a feedstock fuel helps reduce the amount of carbon byproduct that we produce as a waste. So that's why we want to have lots of oxygen available when we burn things, because A, it burns cleaner and has less carbon byproduct. Okay? You can look at it this way as well, and then I'm going to end the lesson here. If we look at complete combustion, this is any hydrocarbon plus excess O2, so enough oxygen to completely consume that. So we can completely consume this, makes CO2 plus H2O. Now, in complete combustion, will be a hydrocarbon, so any hydrocarbon plus insufficient oxygen. We'll make any ratio of carbon plus carbon monoxide plus carbon dioxide plus H2O. And this XYZ stands for the coefficient, and these will be dependent on O2 available. So if we have less O2 available, we'll make proportionately more carbon monoxide and carbon in comparison to CO2. All right? So this is when O2 is a limiting reagent. So not all HC is consumed. So do your oil changes and clean your air filters. Okay, that is it for today. We will do another lesson tomorrow. Thank you.